Hello everybody, welcome to the video for Cumulative Review Packet number 11. In this video we're going to be going from 9b to number 12. So let's start here with 9b. The goal is the same as 9a, though we want to find our critical numbers, put them on the number line, check all of the intervals to see if they're true or false. So if I'd like to start something like part B, I notice right away that we have a greatest common factor, 2 in fact, a GCF of 4 and x squared. And if I take that out, I'm left with x squared minus technically 1x, and then minus 72 is greater than or equal to 0. So this time we had the 0 alone already and didn't have to move anything, so that's nice. So I have 4x squared, and I can continue to factor this quadratic. The two numbers that multiply to be negative 72 and add to be negative 1 are going to be negative 9 and positive 8. And so if I set every single one of these pieces equal to 0, we have a critical number or a root of 9, a critical number of negative 8, and if we set 4x squared equal to 0, we would have a critical number of 0 as well. Now technically it's plus or minus 0, and if we were graphing this, we'd have a multiplicity of 2, but we're not graphing it on a coordinate plane, so we don't need to worry about that. What we do need to worry about is our number line over here. So I'm just going to do this to the best of my ability. It's not going to be perfect because we don't have enough blanks. But I'm going to put 0, the critical number of 0 in the middle. I'm going to put 9 here, and I'm going to put negative 8 here just as a placeholder, just to have it generally on the right side. And so what we need to do is this time we have 1, 2, 3, 4 intervals that we need to check. So when I write the word check over here, we're going to have multiple x values to try. So a number that's clearly less than negative 8, just like last time, I will go with negative 10. You can pick whatever you'd like. A number between negative 8 and negative 8 and 0, I will pick negative 1. A number between 0 and 9, I will pick positive 1. And a number bigger than 9, I will stick with 10. My suggestion again would be plugging it into this factored form and thinking about if your final answer is positive or negative. We want this side to be bigger than or equal to 0 or positive. So if I took negative 10 and plugged it into this, anything squared is always positive. So let's see, negative 10 squared is 100, 100 times 4, so we'd have 400 times negative 10 minus 9, negative 19, negative 10 plus 8, negative 2. Don't really care what this end result is. What I care about is that my final answer is positive, because we have positive times negative times negative. And so if we think about if this makes sense, is a positive number bigger than or equal to 0? Yes, it is. So this region works. And before I keep checking, I would like to point out that I should have put certain dots on these three numbers. Because my inequality is greater than or equal to, these three critical numbers are included. So you'd have closed dots on every single critical number. And this first region worked. This region, if I plug negative 1 into this, negative 1 squared is positive 1 times 4 is positive 4. Negative 1 minus 9 is negative 10. Negative 1 plus 8 is 7. We have a positive times a positive, which is negative. And negative numbers are not bigger than 0. So this region is out. If I plug positive 1 in here, positive 1 squared is 1 times 4 is 4. Plug 1 in here, 1 minus 9 is negative 8. 1 plus 8 is 9. Positive times positive is negative. Negative numbers are not bigger than 0. Out. If I take 10 and plug it into this, 10 squared is 100. 100 times 4 is 400. If I take 400 and multiply that by 10 minus 9, or 1, and then 10 plus 8, or 18, positive times positive is positive. And positive numbers are bigger than 0. So this region works as well. Which means the two regions that are true are the first and last ones. And so if I'd like to write that in interval notation, this interval would be from negative infinity to negative 8. Negative infinity is never included, but negative 8 is in this case. Union, 9 is included, from 9 to positive infinity, not included. This would be your final answer for the intervals that are true in interval notation. Number 10, a 4-meter flagpole is not standing up straight. There is a wire attached to the top of the pole and anchored to the ground. The wire is 4.17 meters long, and originally the flagpole was 4 meters. The wire, this blue, makes an angle of 68 degrees with the ground. So kind of like the angle of elevation, 68 degrees, because this wire and the ground hit right here. What angle does the flagpole make with the wire? So we're looking for this. I will call it X. We're looking for that in the long run. And so we don't know if this is a right triangle, and so we have to either apply the law of sines or cosines. So let's look what we have. We have 68 degrees across from 4, and we have nothing across from 4.17, but we could focus on finding this angle first, and then once we find this angle, then we can go back and find angle X. So what if we did that? What if we used the law of sines, and we said, or set it up like this: the sine of 68 degrees over 4 is equivalent or equal to the sine of the unknown angle y over 4.17. If I cross multiply, I would get 4 times sine y equals 4.17 times the sine of 68 degrees, which means that the sine of y is equal to 4.17 times the sine of 68 degrees over 4, which in the calculator would look something like this. Sine of y is equal to 0.96658 blah, 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 blah. If I want to get y alone, I need to take the inverse sine of both sides. So y is equal to the inverse, or the arc sine, of 0.96658 blah, 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 blah. Make sure your calculator's in degrees, and we would get that y is equal to 75.15 degrees. So we got this is 75.15, but that's not what the problem asked for. The problem asked for the angle between the flagpole and the wire, which we called X at the beginning of the problem. If I would like to find X, I need to remember that the triangle sum is 180 degrees. So it would be 180 minus 68 degrees, which was given, minus the 75.15, which we just found. And if we calculate that, the final answer is 36.85 degrees. Find the tangent of 345 degrees. So we are going to use a sum or difference formula here. So we need to figure out two angles that add or subtract to be 345. I am going to choose to do 120 degrees plus 225 degrees to get 345. So it looks like I'm doing tangent of a sum, and tangent of a sum, according to your identity sheet, is tangent of the first angle plus tangent of the second angle over 1 minus tangent of the first angle times tangent of the second angle. And if you look at your unit circle, the 120 degrees is in the second quadrant, and the tangent value here is negative root 3. You can find this again by taking the y value and dividing it by the x. The tangent value of 225 in the third quadrant, tangent is positive in the third quadrant, and that's going to be a positive 1, over 1 minus tangent of 120 is again negative root 3. Tangent of 225 is a positive 1. So if I simplify this a little bit, the numerator is still negative 3 plus 1, but the denominator with the double negative becomes 1 plus root 3. But we need the conjugate here so that we can simplify and not have a radical in the denominator. The conjugate of 1 plus root 3 is 1 minus root 3. So we have to multiply top and bottom by that conjugate. And if I do so, and I use multiplication or FOIL on the top, I would get negative root 3 Then I would get positive root 3 times root 3 is root 9, which is just 3. Positive 1, and 1 times negative root 3 is negative root 3. And in the denominator, if I use FOIL, these are conjugates, so the middle terms automatically cross out. So I just need to multiply 1 times 1, and positive root 3 times negative root 3, which is negative 3. The numerator ends up being 3 plus 1, 4. Negative root 3 and another negative root 3 is negative 2 root 3, all over 1 minus 3, or negative 2. So if I divide both of these pieces by negative 2, 4 divided by negative 2 is negative 2. Negative 2 root 3 divided by negative 2 is a positive 1 root 3, or even better, negative 2 plus root 3. We will also accept root 3 minus 2. Both are correct. Number 12, given that tangent x is 5/12, and this time we didn't give you the quadrant, so you need to think about what this means. Given that your angle is between 180 degrees and 270 degrees, which quadrant are you between 180, which is here, and 270, which is here? Why, you're in the third quadrant. So you draw your triangle in quad 3, put the x here as the angle, and think about what I gave you here. Tangent is really opposite over adjacent, which means that I gave you opposite and adjacent, which means the hypotenuse has to be 13. But alas, because I'm in quadrant 3, I need to remember that both x and y are negative in quad 3. So if you think about it, it makes sense that the tangent ratio is positive, because if you did negative 5 over negative 12, that is a positive ratio. So please be careful about that if we don't give you the quadrant, to pay attention to the signs. So the goal of this problem is to find the cosine of 2x, which is a double angle formula. And there's 3 of them on your identity sheet, but the most popular one is that cosine of 2x is the same as cosine squared x minus sine squared x, which you can think of as cosine x squared minus sine x also squared. And from our triangle, we know what the ratios of cosine and sine are. Cosine, the ratio from the angle x, is negative 12/13. So we're really taking negative 12/13, we are squaring it, and we are subtracting the sine ratio, which is negative 5/13, and we are squaring that as well. So if I square each of these pieces individually, negative 12 squared is 144, 13 squared is 169, minus negative 5 squared. Negative 5 squared is a positive 25, but we're still subtracting, so that negative stays. 13 squared is 169. Hurrah, we have the same denominator. So now if I do 144 minus 25, my final answer is going to be 119 over 169. What a lovely final answer. All right, guys, again, feel free to do the review packet more than one time. We encourage you to use these videos as many times as you need for a resource. Best of luck studying, and thank you.